Hello friends, welcome to our channel Knowledge Amplifier, and in this particular video I am going to discuss weighted nearest neighbor algorithm. Okay, so in my previous video I have already covered K nearest neighbor algorithm. Weighted nearest neighbor is just little bit modification version of K nearest neighbor only. Okay, so see the code first. Let us check a part of the code, then I will continue my discussion on theoretical part related to weighted nearest neighbor. So CLC clear all, close all, warning off. If you want, you can ignore this line also, no problem in that. Now I am having x and y coordinate of my data points and the class. Okay, suppose there are two class, one class is having 0 and another class is having value 1. Okay, right. So here I have taken some random data points and I have initialized with some class. Okay, then suppose, okay, let me take initial k value. Okay, let me take 5 only, and then a equal to 2, b equal to 4. So we have to find out the 2 comma 4 point in a 2D plane is belonging to which class using k nearest neighbor where k value is 5. All right, then what I am doing, I am basically plotting here the particular data points which we have. If c of I equal to 0, that means if that particular data point is belonging to class 0, then we are plotting using red color plus symbol, and else if it is belonging to class 1, we are plotting using green color plus symbol. Okay, and then here this is our test data point for which we have to determine the class. This particular data point having no class, that is unknown, we have to predict that, we have to classify that using our k nearest neighbor model, right? Then again, from here we are simply using the k nearest neighbor algorithm. All right, so just let me run up to this particular part. Okay, control a, that is for that particular part, and press the evaluate selection. Okay, so before going to the diagram, just let me show you some values. In distance, basically distance is stored, and then we are applying bubble sort, and C, that is class, is also arranged according to the nearest distance. Okay, so if I write distance, I will be getting the values, and if I write the class which are sorted according to the distance, if I run, I will be getting this. So see, for our case, k value we have taken as 5. So nearest 5 values check 11000. So mode for this particular 5 values is 0. So our particular point is belonging to class 0. It seems right. All right. And if you check the distance, see, minimum distance is coming for class 1, second minimum distance also coming for class 1. Okay, and then rest 3, this particular distance are coming for class 0. Okay, so if I go to the plot of the particular data points, I will be getting this kind of graph. Okay, this red are basically indicating which data point. See, those having class 0 are denoted by red color, and those having class 1 are denoted by green color. All right, so basically if you see, this red one are basically class 0 and the green one are basically class 1. Now this is our test data point. Now if you observe the graph itself, you can clearly understand the 5 closest point are these two green points, and this one, and this one, these 3 red points. Okay, so obviously as more number of red points are closer to this particular test data point, so our algorithm should map the particular data point to what? To red, that is to class 0, right? But carefully understand one thing. See, this particular test data point, it is no doubt that it is closer to these green dots only. Although overall mode for k equal to 5 we are getting as red data point, that is class 0, but if you consider the test data point, it is comparatively closer to this green data set. Okay, that is if it is having a tendency to go to class 1, okay, instead of class 0. But if we apply simple k nearest neighbor, obviously it will be giving us class 0, okay, instead of class 1. Now how we can relate this particular concept, that is we will be calculating mode also, but we will be having another priority, that which one is closer. Okay, according to closer close proximity, again we will do some computation. How we can do that? So what I want to say, among 5 closest data point, we should give the weight like this, that the data point which is having at very high distance, that has to be given very low weight, and that is at very comparatively at closer to our test data point, that is when distance is small, for that point weight has to be given more. Okay, so in simple words, weight has to be given more for that point which is having less distance, and weight has to be given less for that point which is having distance more. That is reverse relationship in between distance and weight. So one simple approach what we can do, simply we can give weight equal to 1 by distance. Okay, that's all. So we have done that only here. Now see how I have modified the particular code. Up to this the code is same, and then class C we are taking as empty array. This is basically used to store the first 5 values, and then we calculate mode of class C, right? I have shown you in my previous video, but here we will do one more computation. Frequency of 0 equal to 0, frequency of 1 equal to 0. I am initializing these two variables, and then first k values of the C, that is class matrix, I am storing in class C array. Along with that, we are checking if class is equal to 0, then frequency of 0 equal to frequency of 0 plus 1 by distance of I. That is, we are storing the weight also. If class is 0, we are storing the weight at frequency 0. If the class is 1, then we are storing the weight at frequency 1. Okay. Now what will happen? Suppose for both the case weight is same. Weight for class 0 is equal to weight for class 1. Then we will go for mode. Okay, what is the mode of that particular k data points? The mode will be giving us the result. Else if frequency 0 is greater than frequency 1, then we can say that the among k data points, some data points which are basically coming under class 0, they are closer to our test data point, so we will map our output to 0, else our output will map to 1. So this is simply weighted nearest neighbor. If I run and do evaluate selection, I will be getting this kind of graph, and if I write output and hit enter, I will be getting class 1. Although we can see that for the first, if you take nearest 5 neighbors, the maximum number of nearest neighbors are belonging to red class, which is class 0, but we are getting output as 1 because we are taking weights. Okay, so basically as these two green points are closer to our original data point, so there is a probability that the test data point will more trend towards the class 1 instead of class 0. Okay, so this is how simply you can implement weighted nearest neighbor algorithm in MATLAB. This is what I wanted to show you. Same code I will be posting in the description or in the comment section. If you want, you can check there. This is all for this video. If you find this video helpful, please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.